Introduce yourself and on with the show. Thank you, Sam, for the excellent talk.
Cool, thank you.
Yeah, I'm Dwight Elvey. I'm a fourth hacker from way back, also, I guess. Today, I'm going to talk about a simulator that I wrote, and mention one other thing. This year is the 4004 microprocessor is 50 years old this year. So this is a happy 50th. The simulation I'm actually running is for 4004. So that makes it kind of fun being the 50th year. Okay, let me see if I can share my screen and get something up here to look at. Okay, we'll get this one up here. This one up, yeah, okay. All right, this is the, I don't know if you guys can see it yet, I hope so. Somebody say, yes, I can see some text.
Yes, I see text.
Okay, this is the actual simulator. This is, I thought I'd just kind of go through it real quickly and show you the kind of stuff that's in there. At the top here, I have some general file handling stuff. This is all written in Win32.4. And Win32.4 has file access, but it has very little actual process for handling the files. So this basically allows me to make an input file and an output file. So these are this is what I have here. I don't, in this particular simulation, I'm not using an output file, but I do use it in other simulations. So that's what's involved there. I allocate spaces for the various ROM, I/O, and other functions that I need. I create a the 4004 has, now we're getting into the actual machine of the 4004. Create a stack. The 4004 has a 4-level stack, actually 3-level. One of the levels is actually the current process pointer. So that's basically this fetch that goes there. Then of course there's pushes and pops to the stack. Then the 4004 has a number of 4-bit registers that it uses for most of the general work. So there's little access words here for that. The one thing you want to do with a simulator is you always want to have a cycle counter. If you can practically use a cycle counter, this might be a timer or something like that. The newer processors seem to, with out of order execution and predictive execution, seem to not have correspondence to cycles to actual real time, but they do have a real time counter that you can access. So you want to keep track of stuff like that. I have another value that I keep track of that I call an event cycle, which basically attaches an event to a particular cycle of the processor. And then, of course, almost all simulators, you want to have the breakpoint capability. I only use a single breakpoint, but this could be expanded to be multiple breakpoints, but I just use a single breakpoint for most of my time. And that seems to work relatively well. It's a little clumsy. Sometimes you want to have 2 breakpoints. For instance, if it's going to take a branch, you want to be on, one of the other breakpoints or both of them, depending on which way it goes, while you're debugging. But most of the time, a single breakpoint is adequate. I allocate a space, of course, for the ROM code itself. The 4004 doesn't use very much space, so it only has a 12-bit address. So this is the space I allocate for it. This is where I actually have my RAM space. So this is where the RAM that the 4004 can access. It's a complicated piece of stuff. So it actually has a really oddball kind of RAM. It has this status RAM and regular RAM. The status RAM kind of goes with the different blocks of 16 nibbles. And so it's a confusing thing to look at how it actually works, but this simplifies it so I can keep track of it. So I do all this multiplying so I can keep track of what space I've allocated for these different things. And that's about it. Now we start to get into the actual machine itself, right? There's a thing called a source value that is a register that you have to keep track of, because that tells you how you access RAM and IO. There's a clear instruction to now. What I'm setting up here is the actual instruction table. The way the simulator works is I put all the instruction bytes in this instruction table, which is what I'm allocated here. But it's not actually the bytes. The reference into this table is the byte, and then the actual value that goes here is the execution for that particular instruction. So that's all pretty straightforward. And then of course I clear the table. The 4004, if you give it an illegal instruction, it just treats it as a no-op. So I fill the table with no-ops. You might have special traps there for illegal instructions, stuff like that. But the 4004 will run an illegal instruction, just won't do anything. So, okay, then of course I start to get down into the more meat of the thing, and that's the actual running the actual 4004. I call the 4004 engine, and it's pretty straightforward. I take the PC pointer and fetch the value there. I make that the current instruction because I have to keep track of it. I increment the PC pointer. Since I fetched it, I need now to have it incremented for the next thing. I look it up in the instruction table and execute it. I look at my cycle counts to see if I have an event to execute. The event is a variable so that I can change the event on the fly. It's possible that depending on how complicated your events are, you might want to make this so that it has a stack or a queue of events. But most of the time, it's just a single event I have to keep track of anyway, so I don't worry about that. And of course, also you check for your breakpoint, and executing the done just drops you back to the what you expect it to do when it's done. So that's what that is. You can replace that again, because that's again, it's a value that you can put different things there. So this is just a word I have. I call to breakpoint. It's just basically where you set a breakpoint and then start the engine. And so I use this as my main entry to the simulator. So you can see that it's fairly straightforward. I look for in this case, I'm looking for a keyboard entry to break it. So in case it looks like it's running away, I can stop it and see where I am. And then just pick it up from where I left off. I don't have to destroy it. Just a reset that clears everything. I read the ROM image into the buffer. All pretty straightforward. These are I concatenated into one binary, but this would be the ROM images that I would sometimes look at. Then I have the ability to print the instruction and what's happening at that instruction. So it tells me what the registers look like, the accumulator, and all those kind of things, right? It's a stack display, accumulator display, register display. And then this is just a simple way to execute the that particular thing. The one thing to mention about fourth and the force ability is that you can write little simple words like this that you're going to use over and over again as just one or two characters. So this dot T shows me all the essential things that I need to keep track of most of the time. So I can see the accumulator, I can see what the registers look like, I can look at the stack, I can print what current instruction it's actually this is the next instruction. I take it back that it will execute, so I know what's going to happen next. This tells me what the source value is, which is that that extra pointer that the 4004 has for using I/O and memory. And then, of course, just looking at the RAM, look at the ROM to check things out. Then, of course, now we start to get into the actual executions that will go into the table. This is a generic jump operation here. And more things looking at various specialized register operations, and then the real instructions themselves. And you see that basically what I do, this is a jump on condition, which is a branch. And you can see here that this is how I get it into my instruction table. I tell it what kind of instruction it is going into the table, right? And then I have the actual instruction. So each of these has different kinds of operations. So you see these are, and then of course the rest of it is really just the instructions. So that's pretty much the whole rest of everything that's going to go on is just stick. You know, each instruction has a particular execution. It does something, and you just have to put that in that table so that the simulator can actually run the instructions. And so there's about, I forget, 100 and something possible instructions that you fill in your instruction table. And that's your basic simulator. But to actually run a simulator, especially on a real-time kind of machine, you have to, what I call instrumenting your simulator, which is the actual thing that you're going to emulate, is the more interesting part. And I'm going to I just called it my sim.f here, but it's actually the maneuver board is what I have hooked up here right now. For those, I don't know if everybody knows what a maneuver board is that is a, excuse me, when you're running large ships, you like to know what everybody else is doing around you, whether it's, whether you're in a combat situation or you're something else. So what the maneuver board is it's designed to be able to show you where you might possibly run into something or somebody, and when you might do that, so you know when you might have to make a maneuver to change. Also, it produces what's called closest point of approach, which is also useful for things like if you're going to shoot a torpedo at them, for instance. So, but it's also good for just general shipping, and it's called a maneuver board. You can look it up on the web. It shows you how to plot a maneuver board. And this is a simulation that I got from the Naval Postgraduate School's library. Very interesting piece of code. And the problem is it was all poorly done in a graphical PDF that was off of a poorly typed, looked like ASR 33 with platen with ripples in it, because oftentimes bits and pieces were kind of missing. So I had to actually run this quite a bit in order to get it to run. So these are just the basic little tools to actually run it. The WS is a wait for switch. Basically, there's a keypad with it, and so this is the actual instrumentation for that particular thing. I have a single word that runs the engine and waits for the next keyboard input. So that's what's going on there. And so this particular batch of code is available on my GitHub. So you can actually go out and actually run this and see that it runs. One of the interesting things about it is that because now that you have this up and running, you can actually run real simulations as though you were actually doing what the maneuver board does. So this is like this test 2 here is an actual simulation. Basically, if I've already set up my own ship, I skip this first part because I don't need to do it again. But basically what it is first off, I run the simulation up to where it's waiting for a keyboard input. I do a clear, the keyboard clear. Then I set my speed at, and then that's this here, 20N. N is just a little word I put in there to enter a number into the simulator or into the keyboard. So rather than having to type it myself on the keyboard, I set my course and I display it, and then I hit the button that's called OS, which is my own ship. And then of course here I can put targets in, bearing, time, and distance for the first target. Again, target 2, bearing, time, and distance. That gives it a plottable course. And then I just display everything so I can see what the results are. And so we can actually see that actually happen here. I can run test 2. So what it's actually showing here is the actual entry of this stuff. I have a little bit of funniness here with the extra decimal points here. I modified the code to move where the decimal point was, but my hardware doesn't care. The real physical hardware that I have running on this, so I haven't gone back through and cleaned these up. But that's just a matter of where the decimal point is. So you can see here that
I think you're only showing your IDE. I'm not seeing anything other than
okay,
source.
all right, yes, okay. I have to go back and pick the other one. I just don't know how to do that now. Let me go back here.
Just have to stop sharing and then go back and reshare.
Oh yeah, okay. There you go. Okay, then just do a new, or I could have just done a new share. Sorry about that, folks. It's a lot better if you see what's actually happening here. This one. Okay, you should be able to see that one now.
Yeah.
This is where I've loaded it. Okay, so it just I just load my sim. That brings up the simulator, and then there's a bunch of warnings because I always have duplicates in there. But here at the bottom, you can see I've actually run test 2, and so this is my own ship course and speed in knots, and then here is the other ship that I'm tracking, right? Giving the display here. See if I remember correctly. I think this is the time. Yeah, the time in 24-hour time. This is the bearing, and this is the range. So that gives me that information, and then it prints out the pertinent information about this on this line here, which is what I'm displaying is the actual result of the calculation. So it's telling me that that my closest point of approach will be at this time, another 16 minutes, 0.6. It will be at this bearing, and it'll be a range of that distance. And then this is the actual true course and true speed of my target. So this all done in the 4004 processor. I think it's interesting that this all fits in a 4K of code, that it's using the 4004 basic calculator function. What's interesting is this calculation on the real processor takes about 6 seconds. As you can see here, like for, let's do a test 2, or test 1, I guess, and we'll just do that. And you can see that it's about as fast as it prints out in Windows. So it's the execution is so much faster than the 4004. Even running a simulation on a fairly recent, I guess it's a AMD A8. It says here. So, but it's all kind of interesting that that you can do this stuff, and using these simple instructions. The whole trick is with Forth, of course, is the scripting ability. So anytime I want to change something or diddle with something, I can quickly script it at any level of the emulator or the simulator that I need to get at, and create the necessary pieces. I've recently used this simulator also for I'd been trying to get in the user manual. They have an assembler that a fellow named Tom Pittman. Those that don't know who he is, he wrote the Teeny Basic to run on 6502, and he was in a very early Silicon Valley computer group. He used a 4004 board that he got from Intel to actually do mail list. But anyhow, one of the programs that they have in the user manual or mentioned is an assembler, and he wrote an assembler for the 4004 to run on the 4004 that fit in 1K of code. So kind of visualize that. It's I'd gotten the ROM images early on and had thought there was something wrong with it because it looked like there was a lot of broken bits. Turned out that's just part of the way he wrote it. Very, very compact code. If you like to analyze something like that, it's very interesting to analyze. He used all kinds of tricks. And if you ever wanted to run it on a 4040, you'd have to make some modifications on it because it depends on even the correct stack depth. It uses a stack overflow intentionally. So very, very interesting stuff. Okay, that's about all I have. I haven't looked at the chat, so I don't know what was out there.
All right, maybe one quick question and then let's move on.
Okay.
All right, well, thank you so much, Dwight, for your wonderful talk.
Yeah.
And Ting is raising